So the second type of lift chart is called decile-wise lift chart. Okay. So here the lift is a comparison between an overall average and an average in the decile. So same kind of procedure like before. Okay. You use your training, the model that you've developed using the training data, use that model in the validation data to estimate y hat, and then sort the validation data set in descending order. Okay. And then you divide the entire data set into, now that is already sorted in descending order, into 10 groups. That's why it's called decile. Okay. So within each of the decile, you compute, now you're comparing how well y gets sorted when you sort y hat, when you sort the data in y hat order. So now you look at values of y. So find the average in each of the deciles and compare that with the overall average. So if the sorting of y hat also sorts y very well, then the top 10%, okay, the y average of the y compared to the overall average will be really high, because it's sorting with y hat also sorts y to the top 10% of the cases. So that ratio will be really high. Now as you go down and down the list, the ratio will come down. Okay, so that is your decile-wise lift chart. Okay, so let's look at how to do this in this example. So we have, this is the reason why we needed y bar. Okay, so what we need to do is, this is already sorted by y hat in descending order. So we need to divide this data into 10 parts. And each part we need the y bar value, okay, and then and then the average. Okay, so that's good. So what we are going to do now is to divide this into 10 equal parts. We will use a pivot table. Okay, so actually we need only these two columns. We've already sorted this, so we don't have to worry about the values, the cases being sorted in the order of y hat. That is already done. Okay, so highlight these two. All right, so then pivot table, and we will put the pivot table right here. Okay, all right, and bring in the cases. So this goes from 1 through whatever the last case is, 205 of them. Okay, and then we're going to group it, okay, into 10% each, right? So from one of these values, right click, select the pivot table, right click and group. So now you have 205 observations. So if I divide by 20.5 approximately, so it's not going to be exactly 10% of the cases. So to 20.5, so now that divides these into 10 class intervals. Now bring in y. Okay, so now y is the sum also will work actually. It's not. We can actually use sum. Sum is better than average, okay, because we don't know how many cases are in each of these. If it is divisible by, if number of cases is divisible by 10, then you will have exactly the same number of cases in each row. Otherwise, this will be slightly different. So we are going to be plotting a ratio. So ratio of sum of y and ratio of y bar would be the same thing. Okay. So, and for that we need sum of y bar here. So which means that we need y bar as a field as well. So now we didn't include y bar here, right? So we did not include y bar. So we need that column. So which means that we needed to include up to z. So how do you change the data range so y bar will appear as one of the fields? How do you do that? So make sure that the pivot table is selected, and in the Analyze tab, you see Change Data Source. Okay, click on Change Data Source. So now here go and change it to include up to z. Okay, so then you will have y bar also available to use in your pivot table. If you're able to use, if the number of observations will be exactly same, then you don't really need this. But in any case, so we have, that's your y bar. Okay, so bring that in here. So now we have sum of y bar in each of these class intervals. There are too many decimal places, so here if you want to change the decimal places, how do you do that? So go to value field setting and change the number format. So number format, say 1 decimal place is good. Okay. Now that will be y bar. So let's do y bar. Now what we need is the ratio as you go down. Okay, we want cumulative value of these y's and y bars. So we need cumulative y sum and cumulative y bar sum. So once again, we use sum of C49 to C49, except change that. Okay. And we need sum of D49 to D49. With the first one actually referenced, and then you divide. So this is this ratio is what is left. So how well your cumulative y does with respect to your baseline of y bar. Now this left, if you, it doesn't matter if you use y bar here. That will also do the same thing. The lift will be the same. Okay. So now you copy that down. Right. Let's do some formatting. Right. Okay, so now we are ready to plot. We plot the lift. Okay, so, and this is a bar graph. Okay, so this is decile wise lift for med V. So you see the first 10% okay, has a lift of 1.8. The larger the lift, the better it is. And of course, as you come down, since this is cumulative value, the last 10%, okay, the ratio will be 1 because you're accumulating, so both columns will have the same some cumulated value. Okay, so the ratio will be 1. The smallest ratio will be 1. So the steeper this is, okay, the steeper this is, the better it is. And how quickly it comes down to 1. And then, you know, there should be a really flat line here and really steep decline within the first few deciles and then flattened out. So that's a good decile wise lift chart. A good decile wise lift chart will have a steep decline, very quick steep decline towards the ratio of 1 and then just flatten out to the rest of the way.